Let L be the line of intersection of planes r vector dot 2 I cap plus j cap minus k cap is equal to 2 and r vector dot minus I cap plus 2j cap plus k cap is equal to 2. If point A, B, C is the foot of perpendicular on L from 0, 1, 2, then find the value of 7 times A plus B plus C. You are watching Brain Exploders, the world where brain starts working. Most of us are more familiar with the equation of plane in Cartesian form. So let us see why the equation like 3x plus 2y plus z is equal to 6 represents a plane. If we take ordered pairs x, y, z, different values of this ordered pair which satisfy this equation like 1, 1, 1, 2, 0, 0, 1, 0, 3, 0, 0, 0, 6 and so on, which satisfy this equation. All these points satisfy this equation, and when we create the locus of these points, then they all together make a plane. So that is why the equation, this equation represents a plane. Now this equation can also be written like xi cap plus yj cap plus zk cap dot 3i cap plus 2j cap plus k cap is equal to 6. From here we can take the idea of the equation of plane in vector form, where we represent this xi cap plus yj cap plus zk cap by r vector, and this another vector, another constant vector written the dot product with r vector is the normal, is a vector which is normal to the plane which is represented by this equation. So here this equation, this vector form written over here represents exactly the same plane as above, and here we have so many vectors, so many positional vectors which satisfy this equation, and their heads, locus of their heads represent a plane. So this was the idea of plane in vector form for those who were not familiar with the vector form. Now these are the two planes given to us. Suppose one of the plane is this and another plane is here. Now these are the two planes in the three dimension. Now the line, when they intersect each other, there is a line, their intersection is a line. If we draw a perpendicular from 0, 1, 2 on this line, then its foot is A, B, C. First we have to find this A, B and C, the values of A, B and C. Here if we can find a plane which is perpendicular to both of these given planes and which also passes through 0, 1, 2, then this A, B, C will also lie in that plane. Means this A, B, C will be the intersection of these three planes. The normal a vector normal to the first plane is 2i cap plus j cap minus k cap, which is represented here. With this, a normal vector perpendicular to the second plane is minus I cap plus 2j cap plus 2k cap. Now we have to find a vector which is normal to this third plane. So how can we do it? Let us see. To find, since that normal vector which will be perpendicular to the required plane will also be normal to both of these vectors over here. So we have to find a vector which is perpendicular to both of these. We can find that vector by taking the cross product of these two vectors, 2i cap plus j cap minus k cap cross minus I cap plus 2j cap plus k cap. You can do it directly, or you can use determinant ijk in ijk in the first row, then 2 1 minus 1 in the second row, and minus 1 2 1 in the third row. And you should be familiar with the concept of this determinant. Otherwise you have to use another technique to find the plane which is perpendicular to both of those planes. So this will come out 3i cap minus j cap plus 5k cap on calculation. Now this 3, this minus 1 and 5 are the coefficients of x, y and z in the Cartesian plane if we represent this in the Cartesian form. So the equation of plane perpendicular to both of above planes and passing through 0, 1, 2 will be something like 3x minus y plus 5j is equal to c, and here we have to know the value of c. Since it passes through 0, 1, 2, so this point will satisfy this equation. So if we put this its value, we get 3 times 0 minus 1 plus 5 times 2 is equal to c, or c is equal to 9. Now we have 3 planes. Let's now write them in Cartesian form. It will make the calculations a little bit easy. Now forget about the planes. Just assume, take these 3 equations as equations in 3 variables. Now we have to solve them and find the values of x, y and z, and that will represent the intersection of all these 3 planes. So you can use your own techniques or determinants or matrices, etc. So here I will first eliminate x and y to find the value of z, and then I will find the value of y and then x. So let's multiply minus 1 in this first equation. So the first equation becomes minus 2x minus y plus z is equal to 2. Take second and third equations as they are. So here we have 3x minus y plus 5z is equal to 9. Now add all of them. So x is cancelled out, y is cancelled out, and here we get 7z is equal to 9, because 2 and minus 2 are also cancelled out. So z is equal to 9. In a comma b comma c, this value 9 represents c. Now put the value of this z in the above 2 equations and then solve them. So let us multiply 2 in the second equation. So we get 2x plus y minus 9 by 7 is equal to 2, and minus 2x plus 4y plus 18 by 7 is equal to 4. Now on adding them, we get 5y plus 9 by 7 is equal to 4, and on solving we find y is equal to 33 over 35, and this is the value of b in the point P. Now put the value of x and put the value of y and z in any of the equation and solve them. So we will get the value of x is equal to 41 over 35, and this is the value of a in the point P. Now put the value of a, b and c in 7a plus b plus c. We get 41 over 35 plus 33 over 35 plus 9 over 7 all multiplied with 7, and on solving we get 7 times 119 over 35, which is equal to 119 over 5, and this is the final answer. Don't forget to like and share our video, and for more such videos subscribe to our channel Brain Exploders. Thanks for watching.